Welcome back to another AP Calc video. In this problem, we're going to be talking about this continuous function f. So let this continuous function be defined on the closed interval -4 to 6. The graph of f consisting of 4 line segments is shown above, right here. Let g be the function defined by g of x is equal to the integral from 0 to x of f of t dt. First problem says, on what open intervals is the graph of g concave up? Give a reason for your answer. Alright, so concave up, remember that looks like this. We've got kind of like a smiley face. And a function is concave up when its second derivative is greater than 0 or positive. So if we're defining our g of x as the integral from 0 to x of ft, we can say that g prime of x is equal to f of x, right? Then if we take that one more step further, we can get g double prime of x is equal to the slope of f. So if we want to see where the slope is greater than 0, we can take a look at our graph and see where the slope is greater than 0. So it looks like from -4 to -2 it's increasing, and then from -2 to 0 unfortunately it's decreasing, so we can't include that. And then from 0 to 2 it's also decreasing, so we can't include that as well. But then from 2 to 6 it's increasing again. So I would say that the open intervals are from -4 to -2, and then also from 2 to 6. Okay, that would be our answer for part A. Question B, it says, let P be the function defined by P of x is equal to g of x times f of x. Find P prime of 3. And I've included our g of x again here. So we're being asked to take the derivative of p, so let's go ahead and do that. So p prime of x is going to be, we're just going to apply our product rule here, so it's going to be the derivative of the first times just whatever we had came second, and then plus just our normal g of x times the derivative of f. And so now we're being asked to find it at a specific point, so we can go ahead and plug that in. So g prime of 3 times f of 3 plus g of 3 times f prime of 3. Remember that g prime of x is just going to be, we can cancel out this integral, so it's going to be f of x. So we can rewrite g prime of 3 as f of 3. So now we have basically f of 3 times itself plus g of 3 plus f prime of 3. So g of 3, remember this is going to be the integral from 0 to 3 of f of x. This is basically just going to be the area under the curve of f from 0 to 3. And then our f prime of 3 is just going to be the slope at that point. So let's go ahead and figure out f of 3 first. That should be pretty simple. We can just go back up to, our graph, and we find 3 on our point, and then we see where that correlates to in terms of y, and it looks like it's going to be -3. So we would say -3 times -3. And then to find g of 3, we're going to be taking the area under the curve from 0 to 3 of f of x. So find where 0 is, find where 3 is, and then we want to take the area under the curve, so that would be this area here. So something you might notice is that this area here of this triangle, these two skinny triangles, are going to cancel each other out. Okay, so we have a width of 1 and a height of 4, and our triangle area is 1/2 base times height, so that would be 1/2 times 4 times 1. And then for this triangle here, since under the curve is going to be negative, but since it has that same 1 width and 4 height, it's going to be -1 times 4 times 1. So our end result, when we add those two together, is going to be 0. So we really only have to focus on this area here from 2 to 3. And it looks like we can break it up into 2 shapes, one rectangle or one triangle. So our rectangle area of that is just base times height, so that's going to be 1 times 3. 1 times 3, and then since it's under the curve, it's going to be negative. And then we also want to add, this is a rectangle, and then the area of triangle is going to be 1/2 base times height, which is 1/2 times, it's just 1 by 1, so 1 by 1, so 1/2, and also going to be negative because it's under the curve. So it looks like the area of the curve from 0 to 3 is going to be 0, plus minus 3 plus minus 0.5. So it's going to be minus 3.5. Minus 3.5. Should be a multiplication sign. And then we want to find f prime of 3. So this is actually just going to be the slope at x equals 3 of our f of x. So let's see if we can figure it out. So here at 3. So it looks like the slope, as we go over 1 unit, we're also going to go up 1 unit. So the slope here is just 1. And we know it's positive because our slope is going up. So this would be times 1. Okay, so now we can kind of simplify things out. Minus 3 times minus 3 is going to be 9. And then minus 3.5 times 1 is just going to be minus 3.5. So we're going to get that our answer is 5.5. All right, moving on to the next problem. We're being asked to find the limit as x approaches 2 of g of x over x squared minus 2x. We can find this by plugging in 2 for g of x and our denominator as well. So remember, g of x is just the integral from 0 to x of f of x. So the limit as x approaches 2 would be the integral from 0 to 2 of f of x, and then we plug in 2 down here as well. So maybe if you're looking ahead, you'll notice there's just a little bit of a problem here. So we're going to get our denominator is 4 minus 4, and the area under the curve from 0 to 2 is going to be this here. And if you remember from our last problem, what this is going to end up being is actually 0, because these two areas cancel each other out because the area under the curve is negative. So up top, we're going to get 0, and down bottom, we're also going to get 0, so we're dividing by 0. So we're going to get an indeterminate. So we're going to get an indeterminate form. This is where we want to use L'Hopital's rule. And this says basically that we can take the derivative of the numerator and the denominator and find the limit that way when we have an indeterminate form. Something else that needs to be true is that both the top function and the bottom function have to be differentiable. And I mean, that's true. So for x squared minus 2 of x is differentiable. And since g prime of x is equal to f, which is continuous and defined for all of x, we would say that g is also differentiable. So we can use L'Hopital's rule here. So we're going to take the derivative of the numerator and the denominator. So the limit as x approaches 2. So the derivative of g of x, as we've determined many times from this problem, is just going to be f of x. So we can just write it as g of x first. And then the derivative of the denominator is going to be 2x minus 2. So then we can go ahead and plug in 2. So g prime of 2, which is basically just f of 2 over 2 times 2 minus 2. So what is f of 2? So we find where 2 is on our graph, and it looks like it is minus 4. So we get minus 4 divided by 4 minus 2, so that would be minus 2. So our limit as x approaches 2 of this equation is going to be minus 2. All right, let's move on to part D. It's asking for us to find the average rate of change of g on the interval minus 4, 2. And then we want to see if the mean value theorem guarantees a value c such that it's between minus 4 and 2, for which g prime of c is equal to this average rate of change. Our average rate of change function is going to be f of b minus f of a over b minus a, where we're defining our 2 as our b, we're defining our 4 as our a. So we can say 2 minus negative 4 in the denominator. Make sure you're including that negative and you're not just saying 2 minus 4. The equation says you have to subtract a, and in this case a is minus 4. So since we want the average rate of change of g, we're going to use g up top, so g of b minus g of a. Don't be confused that I'm using f here. This is just like the placeholder for showing the equation. So we want to get g of 2 minus g of minus 4. So remember, our g is the area under the curve from 0 to x of f of t. So g of 2 is going to equal the integral from 0 to 2 of f of t dt, which is going to be the area under the curve from 0 to 2. As we have seen time and time again, this is just going to be 0 because these two areas are going to cancel each other out. So we're going to get 0. So 0 minus. Then we want to solve for g of minus 4. So that's going to be the integral from 0 to minus 4 of f of t dt. We can use the rule that says that we can flip our bounds if we just add a negative out front. So I think this makes it a little bit easier, makes it a little bit more sense that we're moving from left to right. And so now we want to find the area under the curve from minus 4 to 0, and that would be all of this here. So let's go ahead and see which shapes we can break this up into. It looks like we can break this up into a skinny triangle, and then a rectangle, and then another triangle. So the area of our triangle, 1/2 base times height, which is going to be a base of 2, and then the height is from 0 to 6. So this is going to be 6, this area here. Then let's find the area of the rectangle. So that's just going to be base times height. So this is a width of 2 and a height of 4. So 2 times 4, which is 8. And then let's find the area of our little triangle. So it's 1/2 base times height. So it's got a width of 2, or base of 2, 1/2 times base of 2, and a height of 2. So these two cancel out. This is going to be 2. So it looks like if we add this all up to get the area under the curve, it's going to be 16. So we would get that g of minus 4 is negative 16. This is the math that we use to find the area under the curve. So we would do 0 minus negative 16. Remember, the same concept where we need to include both of those signs because we're subtracting g of minus 4, which is minus 16. And then 2 minus negative 4 is 6. So we're going to get that this is equal to 16 over 6, or we can simplify it as 8 over 3. All right, so we've solved the first part of our problem. Now we need to actually use the mean value theorem to see if we can guarantee that value for which there is some g prime of c equal to this rate of change. So our mean value theorem says that if f of x if it's continuous, like this, and if it's differentiable, like this, then there has to be some c such that g prime of c is equal to g of b minus g of a over b minus a, which we found was 8 over 3. We can say that our g of x is continuous because if we take the derivative of it, we're going to get f of x, and so g prime of x is f of x. So since f of x is continuous and defined for all x, then we can say that g is also differentiable for all x and also continuous. So these two are true, so that means by the mean value theorem there must be a c such that g prime of c is equal to 8/3. So by the mean value theorem there must be a value c 4 minus 4c such that g prime of c is equal to 8/3. Hopefully that helps you out with this AP Calculus problem. If you have any questions, feel free to leave them down below and I'll get back to you. And I hope you have a great rest of your day.